Okay, we are working on related rates now, R13, and so let me just touch on a few things about these kind of problems. They can show up on FRQs as part of A, B, C, or D. First, you should always read the problem and try to draw a diagram. Represent what's given mathematically. So if they give you the rate of change of volume, you write dV dt, so you're following along. Then you try to write an equation involving the rate of change, and sometimes this has a little caveat where it has two variables, and somehow you got to get it down to one with other formulas or similar triangles or something. You differentiate with respect to time, substitute all variables back in that you know, solve it, and then make sure you answer the answer correctly. So let's look at the first one. The area of a square is increasing, so this is dA dt, really, right? dA dt, or A prime, twice as fast as its diagonals. So let's call a diagonal z, so the rate with which the diagonal is increasing would be z prime, or dz dt. So what's the length of the side of the square when that's true? So we're given that a prime is equal to 2z prime. Now we need z in relation to the area of a square, the diagonals in relationship to the sides. So if we use the Pythagorean theorem, we know z squared is s squared plus s squared, or 2s squared. So z is the square root of s, or s is z square root over square root of 2, whichever way you're going to end up using it. So the area of a square is side squared, so let's use z over square root of 2, and we get z squared over 2, or 1/2 z squared. Now, we knew that we had a prime is z prime. That was given. No, actually, this a prime is me taking the derivative of 1/2 z squared. That 2 would come down in front. It would be 1z z prime. And these usually involve implicit, okay? Because you don't always have things in, like this is in relationship to z, not t, so that's why it has a z prime. So this is z prime, we knew is the area, so that's a prime, so I substituted z prime in for here and set that equal to 2z prime, which was with the given. So then solving for z, the z primes cross out and you get z is 2. So the diagonal is 2 when their area is increasing twice as fast as the diagonals. So let's just find out what the side is. Remember, back over here the side was z over square root of 2. So the side would be 2 over square root of 2, and if you rationalize that, you get the side is the square root of 2. So that was number 1. Let's go on to number 2. The surface area of a sphere. Okay, so we know the surface area of a sphere is 4 pi r squared, or you should know that. They want you to find that at the instance when the rate of increase of volume, so that is dV dt, right, is 9 times the rate of increase of the radius, so that's dr dt. So we have this equation dV dt is 9 dr dt. Now, what is dV dt? Well, dV dt, or v, is 4/3 pi r cubed, so if we take the derivative of that with reference to t, so it would be implicit, we get 4 pi r squared r prime, and that's equal to 9 r prime. We just set it right equal to there. And so solving for r squared, we get 9 over 4 pi, take the square root, you get 3 over the 2 square root of pi. Now that's not the surface area, that's the radius at the time when the surface area went at this instant that it was asked for. So the surface area, you go put it back into this equation right here, and that's equal to 4 pi R is 3 over 2 square root of pi, quantity squared. So simplifying that out, you get the surface area of 9 units squared. Okay, I'll stop this video and go on to the next.